So I'm quite honored to speak here today. This is a talk about chiseled Java containers we have prepared with my colleague Pushkar. So he unfortunately could not make it today, so I'm only one presenting. My name is Vladimir Petko, and working as a software developer in Canonical, working with Java toolchain. So let me just clarify the topic. So I'll be talking about containers built using OpenJDK package in Ubuntu. So the talk is structured as following. So there will be an introduction about what chiseled containers are, a little presentation of the Chisel tool used to build those containers, presentation of Ubuntu JRE, the runtime for Java that we have built using Chisel, and then I talk about things which are basically work in progress. That's rockcraft, a tool for building OCI compliant containers, rockcraft plugins, extensions for Java. So word experimental because at the moment the Java support in rockcraft in infancy, and the things are basically as in development. And then basically a slide for future work and time for questions. What is chiseled containers? That's basically Canonical's take on Distroless. Distroless was introduced back in 2017 by Matthew Moore, who worked at the time in Google. Now he works at ChainGuard. And the idea was pretty simple. When we are creating a container, we want to package the application, not the operating system and everything else. So we take on the application and its runtime dependencies. So the benefits that were cited in the paper was that this way we are reducing attack surface. We are spending much less time investigating false positives from CV scanners because, again, we have less files in the image. And we have a much leaner software bill of materials due to the same reason. Of course, it was argued that it's much more important to keep the application execution path clean of any vulnerabilities, but it also should be noted that having extra binaries in the image or extra libraries in the image opens way for leaving of the land attacks when the attacker using, say, a shell present in the image. So again, reducing the image size and, let's say, image number of executables in the image is also quite important. So when originally implementing Distroless, they have implemented it on top of Bazel build system. So they have, for example, when building Java Distroless container, they're taking Debian packages and the dependencies of OpenJDK Debian package, unpack it into the root file system, and in the end of the day call it Distroless Java Debian. They have basically moved forward in this regard, so there are projects like Wolfie, APKO, and Melange, where there is a distro based on Alpine, and tools for building the packages for this distro, and APKO is a declarative tool to combine the packages from the distro into the base image. So Chisel takes slightly different approach. Instead of building a special Ubuntu container cloud native distro, we are taking our generic Ubuntu archive, and with Chisel tool, we split packages into functionally related file sets. Let's take libc6 base C library, for example. It consists of libraries itself and jconf character map converters, which are about 8 megabytes. So back in 2001, Fedora had a bug where they split converters into absolutely necessary, like UTF-8, and everything else, basically trimming down the default install of libc. In Debian, the bug is still open, so but nobody addressed it. And in Chisel, we said that, okay, we split the libc into base libraries and G-con converters. And when you say, I want to install libc, you say, I am installing libc-libs, which just installs the libraries without 8 megabytes of converters. So the tool itself is available as snap. So if you're on system supporting snap, you can just snap install Chisel or download it from GitHub. One of the things that was quoted as contra to distress images is that it requires quite a learning curve. So if you want to build a classic distress image, you need to know Bazel, you need to understand how this build system works. In case of Chisel, it's basically one single command line invocation. You say Chisel cut, you specify where are slice definitions for Ubuntu release, or if you don't specify it, it just takes slide definitions for your host Ubuntu system. You specify the output directory and you specify the slices like libc6 libs that you want to install into the root file system. So the slice definitions for Ubuntu archive are available from GitHub, and behind the scenes, Chisel is doing the same thing as Bazel build system for distros is doing. So it downloads the package, downloads the dependencies of the package, and installs it in the root file system. So we have built a runtime image for Java called Ubuntu JRE. At the moment, it's released for OpenJDK 8 and OpenJDK 17. The container is available from Docker Hub, and sources for this are available from GitHub. So OpenJDK 17 is a modular JDK, and if we look at Eclipse Temurin, they have a separate package for JRE, which was brought back. I think it was, yes, around Java 15, maybe. I'm maybe mistaken here. So the build target for OpenJDK is legacy JRE image, which basically supplies a much leaner models file than the full JDK models file. OpenJDK package in Debian and in Ubuntu by extension. There is a package called JRE, but in fact it has a full set of modules. So in fact it's JDK with some binaries stripped out. So if you look at the size of Google distress image, it's pretty large. I think 287 megabytes, and that's in a big part due to contribution of the models file. So for OpenJDK 8, we have rebuilt models using JLink and using the set of models for legacy JRE image target. And for OpenJDK 8 itself, for this image, we have built slice definitions. It's not modular JDK, but the design goal was to strip out functionality not needed to run Spring Boot application. So the base image, so everything except for OpenJDK, again, is pretty much stripped down. So we don't have anything in user bin, anything in var, anything in user share. So no time zone data, obviously no package manager, and only minimal set of library dependencies, which is actually common for all the runtime images based on Alpine. So they don't install fonts, they don't install font libraries, and if you try to do something like get graphics environment with this Azul Zulu distros, you will get a nice crash saying that font manager is not found. Right, so for OpenJDK 8, we have, like I said, removed AWT libraries and dependencies, accessibility support, profiling and debugging agent, and most of the tools, so there is only Java. If you want any of those back, again, we can use Chisel to cut additional slices of OpenJDK into the runtime image that you are preparing. So if you compare the size, it's basically half the size of Eclipse Temurin based on Jammy, so comparing apples and apples. And if we are comparing with minimal images based on Alpine, we are just slightly smaller. So I didn't put it on slide, I apologize, but the comparison is something like 108 megabytes for Ubuntu Jari, and 113 for Amazon Careta Alpine-based. So if you are trying to use it with Docker, then it's pretty simple. Well, of course, it's pretty simple in a basic example. If you want layers support, etc., it becomes not so simple in Docker, and probably the better way of using the base image is using something like Maven JIB plugin, which automates layering behind the scenes. And the premise is pretty simple. You specify a base image that provides Java in your subin, and then you just package your application into this base image. So there is like a small demo that using JIB plugin to build a Spring pet clinic, and I have built it for Temurin, for Google Distroless, and for Ubuntu Jari 17. And just if we compare the sizes, well, then we will see something like 185 megabytes for Chiseled Jari, and 300 megabytes for Temurin, and 287 megabytes, yes, I remembered it correctly, for Google Distroless. And that's again thanks to the models file from OpenJDK Jari package. And as you can see, this pet clinic happily runs, and basically there is no regression in functionality when it comes to running a Spring Boot application. Right, so this was about the base image, but what if you want to add additional dependencies into the image? So yes, it can be done with Chisel card, but we need to take into account the fact that Chisel is not a package manager. So with package manager in Docker, we have one kind of problem. You install additional dependency, and it tries to upgrade packages that are already present in the image. So you have duplicate files in the image, and then you have to squash the layers in order to avoid duplication and still keep the minimal image. Chisel is not a package management tool, so it will cut your dependency that you're installing. It will cut the files that your dependency depends on, but it won't touch any other dependency base image. Sorry. Want to keep it consistent, then you probably want to cut all the dependencies, including the base one, copy it into the target image, and then squash it, same as with Docker. So basically, same trade-off. Now, we have this layers problem with Docker, so we have to be very careful with that, as long as we want to keep minimal size of the image. And also Docker is imperative, basically language you call Docker run, and this means that your build depends on context. You can't really think whether your build reproducible or not, etc. So there is a tool work in development called rockcraft. So it's a tool to build OCI compliant images based on Ubuntu LTS versions. It's available from GitHub. And sorry, it's falling off from me. The difference from Docker is that it's declarative, same as APKO from ChainGuard. So you, instead of layers, instead of sequence of commands in Docker, you specify a set of paths. And if Docker, each run command basically provides a horizontal layer, each path provides a vertical slice of files into the resulting image. So this example is basically have a single path which installs coroutines and base files into the runtime image. Unfortunately, Java support for rockcraft is still in infancy, so there is a lot of scripting involved, and you can't call it truly declarative. So in this case, it's just an example which tries to build Spring Pet Clinic, install Java Runtime, and has a workaround for C certificates Java, which is in Debian, requires us to run a Java file, which Chiseled doesn't support yet, so that looks pretty ugly. And if we try to build this, then we will arrive also to an image that is bigger than optimal one. Again, thanks to models file that comes from OpenJDK package in Ubuntu. So the end result of that is 235 megabytes, which is about 50 megabytes bigger than 186. So just yes. Okay, sorry about that. Anyway, yeah, for rockcraft support, so you have seen this on the right. We have to jump through the hoops to deploy Java Runtime, and that's what I'm trying to build JLink plugin for, so that you have your Java application, and then you have a part that is capable of building runtime for your application tailored to it with JLink. And there is other thing that's present in rockcraft, so-called extensions, and that's basically a scripted sequence of parts that's generated automatically. So it's enough to say extension Spring Boot, and behind the things, rockcraft will execute parts to build your application and to deploy the runtime into the container. So if we are using JLink plugin, then this thing becomes much smaller. In this example, I'm using the private branch to provide dependencies. So if I'm not using private branch, then it would be fully declarative. I will say stage packages and names of the slices. So there is no scripting involved at all. And if we build the thing, then we arrive to the same 186 megabytes that we had with Chiseled Jerry. Okay, so is it playing? Oh yeah, so it's playing. And yeah. So that's a comparison. So we got a small image, and with extensions, it's even better. You don't really have to specify any part. The only key thing here is extension, and the only addition that you might want to add is a service if you want your Spring Pet Clinic to start on startup. And if you want to override something, well, you have a set of predefined names for the parts. So if you want to build Spring Clinic your own way, then you can override it and specify your own build instructions. So here is a small demo of creating a rockcraft file for Spring, again for the Spring demo. So we have rockcraft init command that allows you to initialize the file, and then you just so it has the extension, and then it has a lot of commands that you can uncomment and customize parts of your container. Anyway, so if we package that, then we will arrive to the same small file, and this will be a fully functional example. Okay, so is it probably so here in the demo it's building. There are some traces from moving builds. There are some traces from building runtime image with JLink, and we copy the image into the local Docker. So that's basically the output. And then if we are running it, then it's starting this basic greeting application. Right, so the thing that may be more interested is Gradle plugin for rockcraft. It uses the same idea as GIB plugin, so it's basically apply the plugin to your Gradle project and it will deploy it into Ubuntu-based rockcraft container. So what it does behind the scenes, it tries to detect your build artifact as a jar or boot jar, output of jar or boot jar task. And if it has Beric's Glink plugin, then it will try to grab your application image and deploy it into the target container. And here is like a small sample of that. So it's I think it's again Spring Pet Clinic, and the only thing that I have done is applied the plugin. And the plugin provides following tasks. Create rock, it will create rockcraft YAML file, build rock, build the rock image file on the disk outputs to build rock, and push rock pushes it to the local Docker daemon. So in this example, it just pushed it locally, and yeah, so it was actually some Hello World application that I have built. And in the end of today, that you can see the layout of the container. So it contains Java Runtime, your Spring application, and that's basically it, and just some minimal set of dependencies need to run the Java application. So now, like I said, the Java support for rockcraft is in infancy, so there is like quite a bit of work to be done. So first of all, propagate Chiseled slice definitions for all Ubuntu releases that we currently support. At the moment, the slice definitions 8 and 17 are present for jamming, none for focal, and that's basically work to be done. We have this Gradle plugin, but obviously it can do with some improvements and feedback. And I'm also preparing plugin for Maven, which isn't available yet, but can be tried out from the GitHub repo. And yeah, the overall goal is to finish this work with rockcraft plugins, so that you don't have to use any scripting when you are building images for Java applications. Just use plugins or extensions, basically make Java a first-class citizen for rockcraft. So here are some links related to the things that I have talked about. So there is a rocks community at ubuntu.com, Chisel tool, rockcraft. There is a community for the rock playground that contains this Gradle plugin, Chiseled JRE, and other interesting projects. And here is the last link with the samples that I have used in this demo. We are located in both files, so if you're interested, it will be interesting for you to talk about it, then please come. We'll be happy to answer any questions. So, well, yeah, thank you very much for listening. Yeah, so any questions? No, thank you. Okay.